billion-dollar Mars orbiter captures the closest view ever of an object not from our solar system. And what do we get? A blurry white speck. Within hours, the European Space Agency posts the image. Within minutes, NASA goes silent. And within days, scientists around the world start saying something no one expected. This data doesn't make sense. It's October 2025. The interstellar object 3I Atlas passes Mars, closer than any visitor from another star has ever come. Every major observatory points its instruments toward it. Mars Reconnaissance Orbiter, ExoMars, MAVEN, all ready to give humanity its first detailed look at a true alien wanderer. But what happens next shatters the illusion that science always agrees on what it sees. ESA releases images that look more like static than stars. NASA attributes the missing data to a government shutdown. Independent astronomers claim their backyard telescopes are seeing details orbiters somehow can't. And inside research institutions, leaked emails reveal disagreements over brightness curves, motion vectors, and whether 3I Atlas is even behaving like a comet at all. So what's really going on? Why are the world's best space agencies contradicting each other over an object that should be easy to explain? And what does this silence, this strategic silence, tell us about the limits of transparency in modern science? Stay with me, because by the end of this investigation, you'll understand why some scientists are calling 3I Atlas the object that broke astronomy's confidence, and why the data they're not showing might be more revealing than the images they did. If you believe science should never hide behind closed doors, hit subscribe, turn on notifications, and join the few who still look past the headlines. Because tonight, we're going inside the institutions, the data leaks, and the voices they didn't quote, to uncover how the scientific community really reacted when the universe sent us its third interstellar visitor. It started quietly, almost too quietly for something so historic. On October 3rd, 2025, 3I Atlas brushed past Mars at a distance of roughly 0.19 AU, about 29 million kilometers, the closest pass ever recorded for an interstellar object. For planetary scientists, this was supposed to be a once-in-a-generation alignment, the red planet acting as a cosmic relay station between our instruments and a traveller born beyond our sun. ESA's ExoMars Trace Gas Orbiter, equipped with a CASSIS imaging system, had a front-row seat. Internal schedules leaked a week earlier hinted at target of opportunity tracking windows between 0340 and 0710 UTC. On the night of the encounter, engineers pivoted CASSIS from its usual surface stereo mapping to long-exposure sky tracking, an improvised maneuver designed to chase a dot moving at nearly 210,000 km per hour relative to Mars. 3 days later, October 7th, ESA posted a short announcement. The closest images yet of interstellar object 3I Atlas, captured from Mars orbit. The upload contained 6 frames. Each showed a faint white smear crossing a star field blurred into streaks. No nucleus, no tail, no colour data. And yet, that modest upload would ignite one of the loudest debates modern astronomy has seen. Because at that very moment, NASA, the agency running multiple Mars orbiters with cameras 100 times more powerful, was silent. No high-rise shots, no MAVEN spectra, not even a tweet. When journalists asked, the response was bureaucratic. Due to the ongoing US government shutdown, NASA Public Affairs is temporarily paused. But to those paying attention, the absence felt intentional. If ESA could post, why couldn't NASA? Within hours, screenshots of the ESA images flooded Reddit's r/space, X, Twitter, and YouTube commentaries. Amateur astronomers compared them with their own telescopic captures from late September. Some claimed sharper resolution, others accused agencies of hiding processed data. A viral tweet read, "Billions in orbiters, and we get 6 blurry pixels. Something's off." It gained 2.4 million views before the account went private. Behind closed doors, the first wave of professional reaction began forming. At the University of Arizona's Lunar and Planetary Laboratory, a group chat between imaging specialists debated whether ESA's exposure times matched the expected angular velocity. One scientist, speaking later on Background, said, "The frames look genuine. What concerns us isn't the image, it's the missing metadata. No timestamps, no pointing vectors, nothing reproducible." The absence of metadata meant no one outside ESA could verify the comet's brightness curve, a simple, essential measurement that tells you whether a coma, the halo of gas and dust, is active. Without that, you can't tell if 3I Atlas is inert rock or shedding volatiles like a classic comet. By October 8th, the Planetary Society published a short note, confirming the flyby geometry but urging patience. ESA's images are scientifically valid but not visually compelling. NASA's Mars assets will release data once normal operations resume. Except they didn't. For days, every official NASA channel remained frozen, the silence only broken by automated Mars weather tweets. Meanwhile, private researchers began to stack small anomalies, tiny mismatches between ESA's reported trajectory and amateur astrometry logs. Nothing dramatic, but enough to seed a question that would dominate the next week. Were the agencies even looking at the same object? Inside online forums, that question turned into conspiracy. Inside observatories, it turned into frustration. Because scientists hate information vacuums, they attract noise. On October 9th, a thread titled 3I Atlas, What Are We Not Seeing?, hit the front page of Our Astronomy. The top comment read, "We're not seeing coordination. That's the problem." And that's how the silence began. Not as censorship, but as a chain reaction of bureaucracy, politics and timing that left the world's most curious minds staring at a white dot, demanding answers. For most people, ESA's 6-frame sequence looked meaningless, just a moving dot. For scientists, that dot was a data point, a potential Rosetta Stone of interstellar chemistry. But the deeper they looked, the more contradictions they found. The raw photometry, according to ESA's technical brief, indicated an apparent magnitude near 11.2 at the time of capture, consistent with a modestly active comet several tens of millions of kilometers from Mars. Yet, independent measurements from amateur networks, including the British Astronomical Association's Comet Section and the International Comet Quarterly, reported a brightness closer to 10.6, roughly 60% more luminous than ESA's estimate after distance and phase angle corrections were applied. A difference of 0.6 magnitudes may sound trivial, but in astrophysics it can mean a doubling of reflected light. For an interstellar object, that's huge. It could suggest either a volatile-rich surface releasing dust or an unusually reflective composition. And so, almost overnight, a rift formed between two groups. The instrumentalists, who trusted ESA's calibration pipeline, and the observers, who believed ground-based stacking photometry, revealed something ESA's processing had flattened out. In Geneva, CASI's operations engineer Dr. Nadège Thomas defended her team's numbers in a press Q&A. "We calibrated against standard star fields before and after each exposure. The apparent brightness differences arise from the tracking rate and exposure time, not from suppression or editing." But within hours, spectroscopist Dr. Hiroshi Nakata from the National Astronomical Observatory of Japan posted a preprint analysing the same frames using public calibration stars, finding a statistically significant excess brightness, small but real. His conclusion: either CASIS's dark current subtraction was too aggressive, or 3I Atlas underwent a short-lived outburst at the time of imaging. That single sentence ignited what one ESA scientist later called the photometry war. Because if Nakata was right, ESA's images weren't just blurry, they had caught the object flaring, releasing dust in a micro-outburst that the official processing inadvertently erased. Behind the scenes, internal emails leaked to a science blogger hinted at tension. One correspondence from a CASIS analyst reportedly said, The signal spike is real, but the smoothing algorithm flags it as noise. Another engineer countered, publishing raw outburst claims without cross-verification risks another Oumuamua media circus. The phrase Oumuamua circus became shorthand for every scientist's nightmare, premature speculation gone viral. Meanwhile, the public narrative spiraled further. On Reddit's r Space Policy, users compiled charts comparing ESA brightness to amateur data, labelling them ESA curve and citizen curve. The top-voted post declared, "If amateurs can detect the outburst but ESA can't, what else are they missing?" YouTube channels seized on that divide, pushing thumbnails with bold captions like, "Scientists clash over 3i data, what are they hiding?" Inside the professional community, cooler heads tried to contextualise. Astrophysicist Dr. Anita Carter of Caltech explained in a conference livestream, "At these magnitudes and velocities, differences of half a magnitude are expected. We're looking at motion blur corrections, variable seeing and uncalibrated flat fields. It's not conspiracy, it's error bars. But error bars don't trend. Outrage does." By October 10th, ESA versus amateurs was trending across X Twitter's Science Corner. Dozens of verified researchers spent the night replying to misinterpretations, some even posting their IDL code to prove that a dot is, indeed, a dot. Yet in all this noise, a subtle truth emerged. Both sides were partly right. Later in the week, ESA quietly updated its brightness estimate to 10.9 pleals, 0.3, acknowledging possible transient variation. It wasn't an admission of error, it was science in motion, but online audiences read it as confirmation that something had been hidden. That's when the debate shifted from photons to politics, because now journalists have begun asking, if this is how transparent agencies are with harmless comets, what happens when the data actually matters? A question NASA was in no position to answer, because it was still officially offline, and as one European researcher put it in a private Slack channel later leaked, "The silence from Pasadena is louder than the data from Mars. In science, silence is supposed to mean one thing, we're still analysing." But in October 2025, silence started to mean something else entirely. The US government shutdown that began on October 1st did not technically halt every NASA operation. Spacecraft keep flying, automated sequences keep running, but it did muzzle every public-facing channel. The social media teams, the press offices, even the web publishing staff were legally required to stand down. For Mars missions, that meant the most powerful cameras in orbit, high-rise on the Mars Reconnaissance Orbiter, and the ultraviolet and particle spectrometers aboard MAVEN were still collecting data, but no one could officially say a word about it. Within 48 hours of ESA's CAS's images going public, the contrast was glaring. ESA spoke, NASA didn't, and the internet interpreted that difference not as bureaucracy, but as secrecy. Inside the high-rise operations center at the University of Arizona, engineers continued their normal targeting schedule. 2 short exposures aimed near the predicted 3i Atlas track were logged on October 4th and 5th. Routine test sequences, not high-priority imaging. Normally those frames would appear on the public high-rise site within a week. Instead, the data sat in a queue, waiting for clearance that would not come until October 15th, when the shutdown was finally resolved. By then, the story had already escaped into myth. On social media, speculative posts exploded. One viral thread on X claimed, "NASA caught something they can't explain. That's why no images." Another alleged insider tweet, later proven fake, read, "JPL internal memo, 3i Atlas object showing artificial light curve." Screenshots of these posts accumulated millions of views before moderators could debunk them. The absence of official voices turned rumour into currency. Meanwhile, inside NASA, the scientists themselves were growing frustrated. A senior Mars Reconnaissance Orbiter analyst speaking anonymously to Science News said, "We had good frames, just low SN, The frustrating part wasn't the data, it was knowing we couldn't even say we had it. In an internal email later released through a Freedom of Information Act request, project manager Dr. Kimberly Reyes wrote, "Our teams are complying fully with shutdown protocol. Please remind staff, no unofficial releases or commentary on 3i Atlas until communications resume." That single line, meant to enforce policy, became Exhibit A for every conspiracy forum that week. Screenshots of the email, stripped of context, spread under the caption, "NASA gag order confirmed." Across the Atlantic, ESA public affairs staff watched the uproar unfold. A spokesperson privately told the BBC Science Focus podcast, "We're being accused of hiding data, yet we were the only ones who released anything at all." The irony was painful. Transparency without companionship reads like isolation. Without NASA's simultaneous release, ESA's solitary images looked suspicious instead of commendable. By October 12th, YouTube commentators were weaving the silence into a cinematic narrative. What if 3i Atlas isn't natural? What if NASA's images show structure? One clip set to ominous music racked up 4 million views in 3 days. Actual scientists tried to reply in the comments with exposure time math and angular size equations, but the algorithm favoured speculation. The institutional vacuum had achieved critical mass. When NASA's communications finally resumed on October 15th, the window for sober explanation had already closed. The high-rise team quietly posted a single processed image. No visible nucleus, no anomalies, just another dot. The accompanying caption read, "Observation confirmed ESA photometry within uncertainty." It should have ended the conversation. It didn't. Because by that point, the question was no longer, what does 3i Atlas look like? It was, why did they wait so long to tell us? The gap between data collection and communication had stretched barely 2 weeks. But in the accelerated metabolism of the internet, that was an eternity, long enough for narratives to metastasize. Inside NASA, the scientists were exasperated. One researcher posted privately, "We spend years calibrating a camera to perfection, and it takes 14 days of silence to undo that trust." Outside, the audience had already chosen sides. When official silence becomes deafening, the hum of backyard telescopes grows louder. By October 10th, just a week after 3i Atlas brushed past Mars, the global amateur astronomy community had mobilized into a loosely organized rebellion. These weren't hobbyists with toy scopes. Many of them operated sophisticated robotic observatories, some rivaling university setups in sensitivity. At the center of this surge was a network of small telescopes in Chile, Spain, and Arizona. The Virtual Telescope Project, SLU Network, and the Las Cumbres Observatory Global Telescope, LCOGT. They coordinated observations through Discord servers, Twitter DMs, and shared spreadsheets, cross-referencing predicted ephemerides with actual sky conditions. A thread posted by astrophotographer Liam Ortega on October 11th read, "If NASA won't show us, we'll capture it ourselves." Within 24 hours, hundreds joined his call. Amateur astronomers began uploading long exposure stacks to Cloudy Nights, R Astronomy, and Astrobin. Some even used AI-based sky tracking software trained on prior comet data to isolate the faint moving point of light among Mars' backdrop stars. The results were crude, noisy, but undeniably real. One image from Southern Observatory, Spain, taken on October 12th using a 0.4-meter Newtonian telescope, showed a faint linear structure extending a few pixels beyond the core brightness, possibly the earliest detection of a nascent dust tail. At first, professionals dismissed it as a processing artifact, but 3 days later, when ESA released their follow-up photometric analysis, the same faint elongation appeared in their brightness contours. The amateurs had seen it first. For many, that moment felt revolutionary, a symbolic shift in who gets to make a discovery. Dr. Emily Zhao, a postdoc at MIT, commented during a live stream, "We're watching the democratization of deep space observation. The line between amateur and professional has never been thinner. But the rebellion wasn't purely scientific. It was emotional, a statement against opacity. When NASA remained silent, amateurs didn't just fill a data gap, they filled a trust gap. Their images, annotated and time-stamped, carried something the agencies did not: transparency in real time. Soon, an informal consortium calling itself Atlas Watch emerged, a collective of over 80 independent observers pooling data through Google Sheets and Astro ImageJ. They produced an open-access light curve updated hourly, available to anyone, no credentials required. Mainstream outlets started paying attention. Sky and Telescope published an article titled "The People's Telescope: How Citizen Scientists Beat the Bureaucracy to 3i Atlas." And that was when institutions began to shift tone. ESA quietly joined the Atlas Watch Slack under an anonymous handle to verify their own data against community measurements. Within days, several ESA photometric entries were refined based on cross-validation with amateur exposure timings. In scientific terms, it was a small correction. In sociological terms, it was a tectonic one, because for the first time, a transcontinental network of unpaid observers had effectively audited two space agencies, live, online, and in public. Their conclusion? The dot was real. The outburst probably happened, and the differences in brightness curves were within normal error, not evidence of manipulation. Ironically, the amateurs had ended up defending the very institutions that ignored them, but in doing so, they had proven a larger point. Transparency is no longer optional when every backyard can be an observatory. By October 14th, hashtags like Juggler Atlas Watch and Citizen Science Mars were trending across X and TikTok. Short clips of telescopes whirring under desert skies racked up millions of views. One viral video set to cinematic music overlaid the caption, "While they stay silent, we keep watching." It wasn't rebellion in the traditional sense. It was accountability through optics. Even NASA couldn't ignore it. When the agency finally resumed operations on October 15th, one of the first posts on the official NASA Asteroid Watch account publicly thanked independent observers worldwide for maintaining continuous tracking during the communications pause. A rare gesture and a quiet acknowledgement that public science had become crowd science. That night, Dr. Alan Fitz, an optical engineer who had worked on HiRISE, wrote on his personal blog, "In 1997, it took a government to capture a comet. In 2025, it takes a community." The amateurs had not replaced the professionals. They had reminded them of what the world expects: evidence without delay. But their uprising had an unintended consequence. It forced institutions to respond, fast and publicly. And when they did, the next chapter began. A wave of corrections, clarifications, and uneasy confessions that would expose just how divided the scientific community had become. Science thrives on disagreement, but not on disarray. And by mid-October 2025, disagreement over 3i Atlas was starting to look like disarray. Inside university departments and research Slack channels, the discussion had evolved from "what are we seeing?" to "who do we trust?" The question wasn't whether 3i Atlas was real, it was what kind of object it truly was, and whether the data supported the official story of a natural interstellar comet. Three main factions emerged. The first faction, the traditionalists, argued that 3i Atlas was simply a long-period comet from another stellar system. Icy, volatile-rich, and photometrically typical. They cited the ESA brightness curve, which matched a dust-driven coma consistent with a nucleus a few kilometers wide. Their motto, quoted by astrophysicist Dr. Lucia Romero in Nature Astronomy, "Extraordinary objects do not require extraordinary explanations, only extraordinary patience." The second faction, the dynamics analysts, wasn't so sure. Led by orbital mechanics specialists at the University of Helsinki and JPL's Centre for Near-Earth Object Studies, They pointed out subtle irregularities in 3I Atlas's trajectory. Using publicly available ESA telemetry, they calculated a non-gravitational acceleration slightly higher than expected for solar outgassing at its estimated size. Normally, this might be explained by asymmetric jetting, a common comet behaviour, but the direction of the anomaly didn't align with sunlight pressure. In internal memos later leaked to Scientific American, one analyst wrote, "The radial acceleration component appears anti-solar. It's small but persistent." Those 6 words, small but persistent, rekindled the spectre of Oumuamua, the 2017 object whose odd motion inspired theories ranging from fractal ice shards to alien solar sails. No one wanted to reopen that debate, but the numbers refused to sit quietly. Then came the third faction, the outliers, whose members range from independent researchers to contrarian veterans. They believed the anomalies hinted at something deeper, either a new physical mechanism or an observational error that mainstream groups were reluctant to admit. One of their loudest voices, physicist Dr. Raj Patel, from the Indian Institute of Astrophysics, published a short commentary titled "The Case of the Missing Spectra." In it, he asked a simple but devastating question. Why do we still have no spectroscopic data for an object that passed within instrument range of 2 orbiters and a rover Skycam? The absence of spectra, the fingerprint of composition, was now a scandal of its own. MAVEN's ultraviolet spectrometer had the capability. So did ESA's NOMAD instrument. Neither had released anything, and without spectra the object remained a photometric ghost, brightness without chemistry. Emails later revealed why. Both instruments had indeed collected data, but the results were noisy, inconsistent, and pending calibration. In one leaked message, a MAVEN scientist confessed, "We're getting UV flux where there shouldn't be any. Could be an artifact, could be physics. I don't know which scares me more." The professional press soon picked up on these internal tensions. New Scientist ran the headline, "Interstellar Visitor Divides Researchers. Comet, Rock, or Something New." BBC's Science Focus published interviews with both camps. One ESA chemist downplayed the anomalies. "The signal is within instrument uncertainty. Let's not repeat the Oumuamua panic." But a JPL analyst countered in the same piece. If the data were normal, it would be released. The delay speaks louder than the data itself. As these dueling narratives unfolded, the public began taking sides. Hashtags like #ChusTeamComet and #ChusTeamAnomaly trended simultaneously, with citizen scientists posting mock evidence boards connecting orbital graphs and ESA press clips. What had begun as a simple imaging discrepancy was mutating into a philosophical conflict, a test of how modern science handles ambiguity under global scrutiny. In Geneva, a meeting of the European Space Science Committee tried to cool tempers. Notes from the session recorded one poignant remark from senior astronomer Dr. Otto Kleiber. "We are not fighting about a comet. We are fighting about confidence in our instruments, our institutions, and our ability to tell the truth fast enough for the world's patience." That line became the quote of the week, reposted thousands of times across X and Reddit, often alongside side-by-side screenshots of ESA's blurred dot and NASA's late release. By October 20th, 3 Atlas had receded from Mars and was moving toward its solar perihelion, but the scientific community was still split. Each faction claimed vindication. The traditionalists said the data looked normal, the dynamics analysts said the motion looked wrong, the outliers said the silence looked suspicious, and the truth, it was buried somewhere in a tangle of telemetry, uncalibrated spectra, and human ego. In private Slack channels, some scientists admitted what none would say publicly. The object is less mysterious than our own behaviour. The first leak didn't come from a hacker, or a journalist, or a rogue scientist trying to make headlines. It came from a Dropbox link, buried inside a small private astronomy Discord. The file was labelled simply Maven V26 rawfit.csv. No watermark, no credentials, no context. but inside was data, rows of ultraviolet flux readings recorded between October 3rd and 5th, 2025, corresponding precisely to the window of the 3 Atlas Mars flyby. Within hours, screenshots circulated across R, Space, Twitter, and ResearchGate. A few lines stood out. Unusually high emission values in the 260-280 nanometer band, where water vapour and carbon monoxide typically fluoresce when excited by sunlight. The peaks were faint but distinct, and they shouldn't have been there, not at those distances, not with that consistency. The post that broke it open came from a user named Spectra Ghost, who claimed to be a subcontractor working with a University Maven data calibration team. Their caption read, "If these values are real, something near Mars was emitting UV in a way no comet should." It was the spark that reignited the fire NASA had tried to smother. Scientists scrambled to verify the file. Astrochemist Dr. Melanie Courbet of the CNRS laboratory in Paris quickly cross-plotted the readings with ESA's NOMAD instrument logs, which had been quietly released days earlier in a low-profile data archive. The curves matched, the same anomalous bump at 270 SMEO. She wrote in a public comment thread, "If these datasets are genuine, we're seeing volatile release richer in CO2 than H2O, not typical for a comet, more like degassing from processed rock." Suddenly, speculation became technical again. What could produce an ultraviolet signature like that, without the corresponding infrared spike? Some said photochemical interference from Mars' thin atmosphere. Others whispered darker possibilities, a reflection, an artificial source, a glint that shouldn't exist. Within NASA, chaos quietly brewed. Internal emails obtained weeks later through FOA show that Dr. Kimberly Reyes, the same project manager who enforced the communication freeze, convened an emergency teleconference on October 16th. The agenda line read, "Unauthorized Maven dataset circulating. Confirm authenticity, assess breach impact, prepare unified statement." In that meeting, according to an internal summary, 2 interpretations were debated. One side insisted the anomaly was instrumental noise. Maven's UV spectrometer had known calibration drift near that wavelength. The other argued it was real emission, possibly from sublimating materials not previously observed in interstellar comets. The call ended without consensus, but the damage was done. Because now the story had escaped containment, independent analysts began replotting the leaked dataset, applying their own dark current corrections. Astro Twitter lit up with graphs. Some confirmed the anomaly, others dismissed it. Within 2 days, The Atlantic, New Scientist, and Space.com all ran versions of the same headline. Leaked NASA data hints at mystery around interstellar visitor 3I Atlas. NASA's official response came late and careful. The data in question appears to be uncalibrated intermediate telemetry. It is premature to draw conclusions. But that only deepened the intrigue, because intermediate telemetry meant it was real, and real data, even uncalibrated, meant someone had broken ranks to show it. Then came leak number 2. On October 18th, a compressed archive appeared on an academic file server registered in Belgium. Inside were early ESA NOMAD UV spectra, marked Draft V3. Unlike the Maven file, these were clean, time-stamped, and traced directly to ESA's internal repository. The spectra revealed faint but repeating lines consistent with cyanide compounds, CN bands, the kind sometimes seen in hypervolatile rich comets, but the intensity ratio was off by nearly 40%. Translation: the chemistry didn't fit any known cometary model. A whistleblower later identified only as K47, who claimed to be part of ESA's instrument analysis team, told The Guardian, "We saw the CN bands early, but the ratios were all wrong. It looked like the gas had been exposed to intense radiation before emission. We were told to hold publication until after calibration. That was code for don't release until the Americans catch up. Whether that statement was true or coloured by frustration, no one could prove. but it fed a narrative that was now too compelling to ignore. The agencies weren't collaborating, they were competing. Meanwhile, citizen analysts began merging the leaked datasets into a single composite spectrum. The community effort dubbed Project Mirror was born. Using open-source software, they plotted UV and visible band readings against standard cometry templates. The result? A distinct spectral slope inconsistent with water-dominated comets. Flatter, more metallic, possibly carbon-rich or containing refractory silicates. That alone wouldn't be shocking, except the same pattern had been seen before, in 2017, in Oumuamua. That connection set the internet ablaze. Comparisons flooded forums. Is 3i Atlas Oumuamua's twin? Are these interstellar objects part of the same origin stream? Professional astronomers bristled. The math didn't support such claims, but they couldn't unsee the resemblance. ESA finally broke silence on October 20th, issuing a carefully worded release. Spectroscopic analysis of 3i Atlas continues. Preliminary results suggest atypical volatile composition compared to solar system comets. No evidence supports artificial origin. For the first time, the words "no evidence supports artificial origin" appeared in an official statement, unprompted. To many, that phrasing said more than it denied. By now, two realities existed side by side. In one, scientists were performing cautious, methodical analysis. In the other, the public saw a global cover-up unravelling in real time. But leaks are contagious. Once one appears, others follow. And the next one wouldn't come from inside an agency. It would come from a government contractor who'd seen the Mars orbiter's thermal imaging data. And what it revealed would shake even the skeptics. By the third week of October 2025, the mystery surrounding 3i Atlas had officially left the optical spectrum. It was no longer about what we could see, it was about what we could feel in heat. The leak appeared first on a German astronomy forum late on October 19th. A user going by Marinerd posted what looked like a cropped infrared image, grainy, high contrast, stamped with the unmistakable outline of ESA's trace gas orbiter metadata bar. The file name, Tijo Igia Fulzerufru OCT25 forbidden.jpg. The word forbidden wasn't a coincidence. According to several insiders later interviewed by Der Spiegel, that label referred to a flagged frame from the orbiter's Freon infrared spectrometer, FIRSPEC, a calibration sequence that had been manually tagged for internal review and excluded from automated data upload. Why it was excluded would soon ignite one of the most contentious debates in planetary science history. The leaked image, once digitally cleaned, showed 3i Atlas as a faint, elongated smear with an infrared thermal signature, hotter than expected by 47 Kelvin, roughly 143 D, when the model predicted 190 D for an inert comet at that solar distance. That 47-degree discrepancy might not sound dramatic, but in astrophysical terms it's an alarm bell. Something was emitting heat, or reflecting it in a way natural dust shouldn't. Thermal engineer Dr. Nina Bergström from the Swedish Institute of Space Physics explained it bluntly during an independent livestream. At that distance from the Sun, only active sublimation or internal heating could produce that kind of temperature. The question is whether the heat came from the Sun, or from the object itself. Her words echoed across Reddit, Twitter and YouTube like a signal flare. The hashtag #ForbiddenFrame trended for days. Within 24 hours, multiple experts attempted to reproduce the result. Using publicly available thermodynamic models for cometary dust, they confirmed that even aggressive CO2 outgassing couldn't sustain that temperature difference for more than a few minutes. The only other explanation was a transient internal heat source, perhaps a volatile-rich core, perhaps something no one wanted to speculate on the record. Then, another image surfaced. This time, the leak came from a cloud storage account linked to a subcontractor for Thales Space, one of the companies that helped build TGO. The file, labelled FIRSPEC RAW L3B 3twin.zip, contained unprocessed thermal frames. In one, a pixel cluster corresponding to 3i Atlas showed a brief infrared flare lasting approximately 4.8 seconds, a burst that faded immediately in the next exposure. Statistically, it could have been a cosmic ray hit. But the pattern was too symmetrical, too consistent with a real object. Within hours, thermal analysts were running simulations. The French group Astrodata FR concluded that the flare could represent a rapid exothermic venting event, possibly linked to internal crystallization of amorphous ice, a natural phenomenon seen in some comets. However, the American researcher Dr. Paul Resnick, reviewing the same frames, found the flare's spectral profile too narrow for venting. His conclusion: the wavelength peak looks more like a transient reflection of collimated radiation, like a flash. A flash. That single word turned an otherwise technical debate into the story of the week. Every major science outlet picked it up. The Guardian: Mars orbiter detects flash from interstellar object. The Atlantic: heat west none should be, the forbidden frame controversy. ESA's public statement, released the next morning, tried to douse the flames. Preliminary analysis suggests the anomaly results from sensor saturation during attitude adjustment. No abnormal heating detected. But that only deepened the intrigue. The leaked metadata in the image clearly showed no attitude change logged during that time. Someone was lying, or at least omitting inconvenient details. Inside ESA's operations division, tensions were rising. An engineer, later verified through metadata crosschecks, wrote anonymously to Le Monde: "We were told to mark the frame invalid, not because it was corrupt, but because it raised too many questions too early." The phrase "too early" became a rallying cry for the online community, who now saw 3i Atlas as the next chapter in a growing pattern. Data that didn't fit the model, locked away until it could be explained. In private emails among scientists, later quoted in Nature News, one astronomer confessed, "I don't think anyone's hiding aliens, I think they're hiding confusion." And that may have been the most honest answer of all. By October 22nd, the forbidden frame had been downloaded over 20 million times worldwide. Citizen analysts recreated the heat map, confirming the anomaly but unable to pinpoint its cause. ESA quietly replaced its online press kit with a revised dataset, omitting the infrared reference entirely. The change was caught within minutes by archive bots and reposted across Reddit under the title "Deleted Confirmed." In 1 week, an interstellar visitor had become a mirror reflecting humanity's unease with uncertainty. Heat meant energy, energy meant process, and process, unexplained, meant controversy. But while the world argued about a 5-second flare, a quieter, more disturbing revelation was brewing, hidden not in imagery, but in the patterns of silence themselves. Because as journalists began tracing communication logs between ESA, NASA, and the European Commission, they discovered entire data packets that had never been publicly acknowledged. Transmissions relayed from Mars, logged, and then scrubbed. And that trail led to the next chapter of our investigation. What exactly was removed, and why? If every mystery leaves a footprint, then 3 Atlas left a trail of silence, a digital silence written in missing numbers. By the 4th week of October 2025, amateur data sleuths had grown bored of debating pixel brightness. Instead, they started comparing timestamps, the hidden metadata embedded in ESA and NASA telemetry logs. That's when something strange appeared. On October 24th, a small software engineer from Warsaw named Marek Lewandowski noticed that in ESA's official archive, the Mars Trace Gas Orbiter logs jumped from 0312 and Wavethor UTC to 0316.22 UTC on the morning of October 3rd, right in the middle of the 3i Atlas tracking sequence. 4 minutes and 18 seconds of missing telemetry. No transmission drop, no recorded error, just a gap. When Marek cross-checked with archived relay logs from NASA's Deep Space Network, DSN, receivers at Canberra, Those minutes did exist. Their packet IDs matched the sequence gap exactly, but in ESA's version, the packets were gone. He posted his findings on GitHub with the blunt title, "Gaps in ESA TGO telemetry, missing data or missing disclosure." The thread went viral. Within hours, dozens of coders began scraping mirrored datasets, compiling packet hashes from public servers. They found 11 missing intervals across 3 days, totaling 31 minutes of erased telemetry. Each cluster corresponded to key observation windows when TGO's cameras and spectrometers were aimed at 3i Atlas. At first, ESA brushed it off. A spokesperson told Reuters, "Small telemetry gaps are normal and occur due to relay congestion." But the problem was, this time, the DSN data proved otherwise. There was no congestion. The signal was clean, unbroken, and verified by at least 2 independent relay stations. Then, on October 25th, another anomaly surfaced. A Redditor named Astrosyntax discovered that the checksum for packet TGO 2002-6, part of the missing block, had reappeared briefly in a European Commission mirror server before being purged within hours. He archived the checksum hash and the timestamp, incontrovertible proof that the packet had existed, uploaded, and then deleted. The post headline read, "They didn't lose the data, they removed it." That sentence became the spark for an information wildfire. Journalists began requesting comment. ESA's communications team insisted that the deletions were routine housekeeping, redundant backup removal. But cybersecurity analysts at the European Data Transparency Initiative found something else. Traces of 2 file purges tagged with the classification EO reserve, a designation typically used for restricted Earth observation data, not open astrophysical datasets. Why was interstellar data treated like classified Earth surveillance? That question made its way into the European Parliament's Committee on Science and Industry briefing by October 26th. An internal memo from committee, Chair Petra Van Halen summarised it starkly. ESA's handling of the 3i Atlas dataset may have violated open data protocols. The agency must explain the disappearance of these transmissions. The following day, a whistleblower identifying herself as E. Markers, allegedly a systems technician for ESA's data management division, posted an encrypted statement to Pastebin. The document contained log excerpts from the missing time block. One line stood out: priority, flag delayed release class Thuren object. That tag, if genuine, meant the data was intentionally withheld, not lost. The revelation reached mainstream news. The Guardian ran the headline, "ESA accused of selective deletion in 3i Atlas case." CNN's science desk phrased it even more sharply. Leaked logs suggest suppressed Mars transmission data. The public backlash was instant. ESA released a late-night statement attempting to contextualize. Certain telemetry streams were flagged for further verification due to calibration uncertainty. The flagged segments were never intended for deletion and will be restored in upcoming data releases. But when the upcoming release arrived 2 days later, the data blocks were still absent, replaced by placeholder text reading, "Data segment under technical review." It was digital censorship disguised as caution. Meanwhile, independent data archivists began noticing something subtler. In NASA's Planetary Data System (PDS) repository, 2 inbound files from ESA, normally mirrored automatically, had been replaced with newer versions timestamped 5 minutes later but identical in size. Binary comparison showed slight variations. Less than 0.1% of bytes differed. Yet within that 0.1% were the headers containing time and orientation tags, effectively erasing any trace of the object's real trajectory during those minutes. It was an old trick. Revision without deletion. Keep the files, change the metadata, deny everything. By October 28th, multiple digital forensics teams, including the volunteer group Open Space Data, confirmed that at least 3 organisations, ESA, NASA and the European Commission, had all edited their mirror archives within a 48-hour period. No one could explain why. A former ESA communications officer, speaking under condition of anonymity, offered one chilling interpretation. They weren't hiding an alien, they were hiding uncertainty that could look like one. In other words, the data may have shown something mundane but ambiguous enough to spiral into chaos if misinterpreted. And rather than risk another public spectacle, the agencies hit delete. But deletion is a form of confession, because in every system what vanishes leaves metadata behind, ghosts of entries that once existed. When a French coder reconstructed those ghost packets from residual log headers, he found the final recorded field before deletion. It read, Object ear signature, persistence, Joso 4.2 seconds. Exactly the duration of the mysterious infrared flare, the forbidden frame. The missing transmissions hadn't just vanished randomly, they vanished right when the object glowed. At this point, the story was no longer about astronomy, it was about accountability, and that's when government stepped in. Because the next set of documents wouldn't come from scientists, hackers, or enthusiasts. They would come from official investigation orders, quietly filed under the European Commission and leaked days later. And what those papers revealed would transform a scientific debate into a geopolitical event. By the final week of October 2025, the 3i Atlas story had escaped the gravity of science. It was no longer about spectra or thermal anomalies, it was about control, of data, of narrative, and of fear. In Brussels, the European Commission's Directorate General for Space Policy called an emergency session on October 29th. The topic, data governance irregularities in the 3i Atlas observation campaign. Officially, the meeting's minutes were sealed. But journalists from Le Soir obtained a draft summary. One line leapt out. Coordination failure with US partners has led to reputational risk and unverified public speculation. Translation: ESA's credibility was bleeding out online. They needed to stop it. Across the Atlantic at NASA headquarters in Washington, administrators faced a mirror problem. The shutdown had ended, but the silence hadn't. The Office of the Inspector General had begun quietly reviewing internal communications after multiple whistleblower claims that foreign agencies were withholding shared telemetry. In other words, NASA suspected ESA of editing their uploads before mirroring them to the US database. Meanwhile, ESA suspected NASA of leaking internal data to deflect blame. Two allies, bound by decades of cooperation, now behaved like rivals guarding a state secret. Behind closed doors, diplomatic cables flew. The US State Department requested clarification under the Bilateral Data Exchange Accord, 2016, a treaty that guarantees reciprocal access to space science telemetry. Brussels responded with one sentence. Certain records have been reclassified pending security review. Security. That single word detonated across social media. Because security had no place in open astrophysics, unless someone, somewhere, feared what the data implied. By October 30th, leaks reached journalists at Politico EU. They published the headline, 3i Atlas. Data falls under new European Space Security Directive. The article cited two unnamed officials claiming the data was temporarily restricted due to dual-use potential. When pressed, the Commission declined to elaborate on what dual-use meant, a term usually reserved for technology that can serve both civilian and military purposes. The reaction was immediate. Conspiracy channels called it proof that 3i Atlas was artificial. Mainstream outlets called it bureaucratic paranoia. But inside government halls, a quieter concern took shape: precedent. If an interstellar object could trigger international classification disputes, what would happen when the next one arrived? Closer, brighter, maybe on a trajectory intersecting Earth's orbit. NASA's Public Affairs Office drafted an interagency statement calling for renewed transparency and collaborative data integrity. ESA's legal team struck out the word transparency. They replaced it with coordinated communication strategy. The semantic shift said everything. Meanwhile, scientists caught in the crossfire began leaking again. This time not data, but emails. Messages between ESA and the European External Action Service, EEAS, revealed an uncomfortable truth. The European Union had briefly considered invoking Article 7 of the Space Security Framework, which would have allowed them to classify 3I Atlas observations as potential extraterrestrial contact data. A clause written decades earlier during the SETI boom and never used until now. It was meant for signals, not rocks. But bureaucracies fear optics more than physics. At NASA's Jet Propulsion Laboratory, Director Dr. Leroy Matheson pushed back. In a memo leaked to the New York Times, he wrote, "Science cannot function under a regime that treats data as diplomacy. The universe doesn't recognize our borders." The quote became iconic, printed on protest signs outside ESA headquarters in Paris, where demonstrators gathered carrying telescopes and cardboard comets, painted with the words, "Let us see the data." By October 31st, a 3I Atlas reached its perihelion, 1.38 AU from the Sun, while on Earth, the storm of politics eclipsed the light of discovery. The European Parliament announced an independent inquiry into data suppression. The US Congress requested a briefing from NASA on foreign-held space data. And quietly, the United Nations Office for Outer Space Affairs scheduled an extraordinary session to discuss international standards for interstellar object reporting. For the first time in history, an object from another star had forced humanity to confront its own fragmentation. Scientists wanted answers, politicians wanted control, and the public wanted truth, or at least the feeling of it. One senior EU advisor summed it up in a private note later obtained by Der Spiegel. 3I Atlas is not a crisis of science, it is a crisis of confidence. Outside, telescopes kept tracking the fading dot as it curved away from the sun, growing dimmer by the hour, slipping toward the edge of detection. Inside, committees argued over ownership of light itself. By November 1st, a fragile compromise began to form, a joint ESA and NASA release scheduled for mid-month, promising complete transparency. But insiders already knew what that meant: heavily curated data sets, carefully worded statements, and months of review. The raw truth would remain classified, not because it was terrifying, but because it was unfiltered. And as 3I Atlas receded into darkness, one question lingered, whispered among scientists, reporters, and late-night observers alike. If the next visitor behaves the same way, will we learn from this storm, or repeat it? By mid-November 2025, the object that had dominated headlines for a month was gone. 3I Atlas slipped past the Sun, crossed 1.8 astronomical units from Earth, and dimmed below magnitude 17, too faint for most telescopes to track. In the cold vacuum where it came from, it was once again anonymous starlight. On the ground, though, the echoes remained. When ESA and NASA finally released their joint transparency report on November the 20th, it landed with the thud of overcuration. 200 pages of sanitized data tables, calibration notes, and identical executive summaries. Every controversy flattened into technical language. The forbidden frame was relabeled a thermal sensor anomaly. The missing telemetry became a synchronization event, and the ultraviolet spike, inconclusive, pending further modelling. But hidden in the appendices, careful readers noticed a quiet concession. The average surface temperature of 3 Atlas was indeed warmer than predicted by 40+, 6 Kelvin. No explanation was offered. No follow-up was planned. In scientific journals, a dozen papers trickled out over the next 6 months, each addressing a fragment of the puzzle: coma composition, orbital mechanics, photometric variance. They disagreed on almost everything except one point. 3I Atlas had been unlike any comet we'd seen before. Whether that meant exotic chemistry, structural porosity, or something unimagined, no one could say with confidence. In politics, the fallout lasted longer. The European Data Inquiry concluded that administrative miscommunication had led to premature deletion of telemetry, a polite way to say nothing while admitting everything. NASA's internal review found no evidence of malfeasance, but recommended a new open planetary data charter mandating simultaneous public release of all interagency observations. For the first time, data transparency became a campaign promise, and yet public trust had already fractured. Where once people argued about whether interstellar visitors existed, they now argued about whether science itself could still tell the truth. Universities faced online harassment for perceived censorship. ESA's outreach channels shut down comments after repeated attacks. Even legitimate findings were dismissed as propaganda. But not everyone walked away disillusioned. In backyards and garages around the world, the Atlas Watch network endured, the same citizen scientists who refused to let silence win. By December, their open-source portal hosted every unfiltered image of 3i Atlas, complete with timestamps, calibration files, and community-verified metadata. No ads, no politics, just photons. When reporters asked founder Liam Ortega why he kept it running, he said, "Because space belongs to whoever's looking up, not whoever's signing off." His words resonated. Within a year, universities began partnering with citizen observatories for comet tracking programs. Transparency had found its champions, not in institutions, but in individuals. As for the scientists who lived through the chaos, their reflections were quieter. Dr. Lucia Romero, the traditionalist from Nature Astronomy, later admitted, "The real discovery wasn't out there in the dark, it was seeing how fragile our systems are when they're forced into daylight." Dr. Raj Patel, the critic who demanded the missing spectra, put it another way. "We learned that a single line of deleted code can erase public faith faster than any alien signal could restore it." And perhaps the most haunting reflection came from Dr. Kimberly Reyes, the NASA manager once accused of suppression, who finally spoke publicly during a symposium months later. "We didn't hide the truth. We hesitated to share our confusion, but in an age this connected, hesitation is concealment." Her words became the unofficial epitaph of the entire event. Today, 3 Atlas is a fading coordinate in the archives. RA 16A22 DEC Plodel 3D. Its photons are long gone, but its shadow lingers in policy documents, academic reforms, and 1,000 online debates. It forced humanity to confront a question we thought we'd already answered. When the unknown appears, do we protect the truth or the illusion of control? The answer, as always, depends on who's watching. Because somewhere beyond Jupiter, the faint glow of 3i Atlas continues its journey out of the solar system, carrying with it the data we lost, the questions we buried, and the reminder that discovery doesn't belong to the silent. If you followed this investigation to the end, you're part of the reason these stories still matter. Truth in science isn't a headline, it's a pursuit. Subscribe, stay curious, and question everything. Not to doubt the world, but to keep it honest. Because the next object is already on its way, and when it arrives, what we've learned from 3i Atlas will decide whether we see it clearly, or lose it in the noise again.